Reciprocal trig. What is 1 over sine equal to? Cosecant. Or abbreviated CSC. What about the reciprocal of cosine? X abbreviated CC. And what about the reciprocal of tangent? X COT. All right. Absolutely foundational at its core identities. Sine over cosine. What is it equal to? Tangent. Yeah, tangent is, we said about this a couple of seconds ago, tangent is y over x. That's the same as sine over cosine. So you should definitely have deep down in your brain tangent is sine over cosine, which makes it in a unit circle just the ratio of the y to the x. Cosine over sine then is the reciprocal of tangent, and therefore tangent is sine over cosine. Cotangent is cosine over sine. So if you like, you can find the cotangent by taking the x over the y, and the tangent is the y over the x if you have a unit circle and points. All right, so cool. Let's proceed on with the old day then. Relationship secant. Let's start with an xy relationship. If cosine is x over 1, cosine is adjacent to the hypotenuse, and in the unit circle, the hypotenuse is 1, so x over 1. If cosine is x over 1, then secant is 1 over x. Now, if we were to draw 135, that's what kind of reference triangle? In what quadrant? Second quadrant. So it's a 45-degree reference triangle. And what is the sine? Well, it's the same as cosine. Taking the reciprocal doesn't change the sign of it. So if cosine is, what sign is cosine in the second quadrant? Negative. Think the x, right? Do you agree that in that quadrant x is negative, and so the quadrant sign is negative? Now then, as far as the actual numerical answer, we need to actually get the x. What is the x side of a 45, 45, 90? Square root 2 over 2. So it's negative 1 over square root 2 over 2. Now that's a bit of a mess, so let's go through a little bit of cleanup. That's the same as negative 2 over root 2. If I take the reciprocal, do you agree? And if I then clean that up by getting rid of the root, I multiply by root 2 over itself, which eventually gives me negative 2 root 2 over 2. And so what's my final answer I arrive at? Negative root 2. Okay? So you're going to start to want these to be familiar. Anytime cosine is root 2 over 2, secant will be root 2. Cosine is negative root 2 over 2, and the secant will be negative root 2. All right. So that'll start to look familiar. Cotangent, 2tan. Cotangent is x over 1 over tangent, or cosine over sine, or what variable relationship, x and y? Is it x over y or y over x? Tangent is y over x, so cotangent is x over y. Right? What kind of related angle am I looking at? 210 degrees is what kind of reference angle? 30 degrees, and in what quadrant? Third. Okay, so it's a 30-degree related angle there. What's the quadrant sign given that we're looking at x over y? What are the signs of x and y? Negative and negative. So the overall sign of the cotangent is positive. All right, so we should get a positive result. And then let's talk the sides. The x side is the long side. What's the long side of a 3069? Root 3 over 2. And what's the short side of a 3069? 1/2. And if the 2's drop out, then I just get a positive root 3. Wait. Cosecant of 5 pi over 6. Pi over 6 is what kind of reference angle? 30 degrees. oops, wrong, I jumped ahead, Bob, sorry. Cosecant is the reciprocal of which function? Sine, all right. And sine is what variables, x or y? Y. All right, so sine is y over 1. So cosecant is 1 over y. And when I go to draw this, pi over 6 is a 30, 60, 45, what? 30-degree angle. And isn't this pi? So do I want to go a little short of that, so above, or a little past that and below? A little less than that, so above. So I have a 30-degree, or pi over 6 angle there. And let's talk sine. It's 1 over y, and what's the sign of y there? Positive, so we're going to get a positive. And it's 1 over whatever the y is. What is the y, given that y is the short leg? What's the short leg of a 3069? 1/2. What's 1 over 1/2 cleaned up? So where sine or cosine is 1/2, then secant and cosecant will be 2. Secant of negative 3 pi over 4. Secant is the reciprocal of what? Cosine. And so instead of x over 1, it's over x. Pi over 4 is what kind of reference angle? And what quadrant do I end in? Given it's a negative angle, a little less than pi. So yeah, I'm gonna go this way, but I'm not gonna quite go pi, and so I end in the third with a 45-degree angle. Okay. What about the sign there? You said it's 1 over x, and if x is positive or negative there? X is negative there, so our answer will be negative. All right. And 1 over the x. What are the legs of a 45, 90? Root 2 over 2. So it's 1 over root 2 over 2. And I've done that already. When I deal with that 1 over root 2 over 2, how does it eventually pan out? Root 2 over 2 or just root 2? Just root 2. I don't need to show all that. Rational. Negative. Oh, yep, sorry. Forgot my sign. Negative. Good point. Thank you. Okay. Cosecant of negative 90. Alrighty then. Cosecant is the same, or reciprocal of sine. Sine is 1 over what? 1 over y over 1, so this cosecant is 1 over y. I agree there. Okay, step ahead of me. I'm going to draw this just for the kicks of it. But negative 90 puts me at the negative y-axis, yay? Okay. What is the y sign there? Negative. And what is the y value there? 1. And it's 1. Do you agree? So what do we get? Negative 1. All right. Last one, cotangent. Cotangent is reciprocal of tangent. And tangent is y over x, so cotangent is x over y. Cotangent is x over y. Pi over 4 is what kind of reference angle? 45. And I'm going up and over. Am I going to the x-axis or before or after? After with a 45. I didn't make that. Yeah. Okay, it's a 45-degree angle after the axis. What are the signs of x and y there? Well, negative, therefore yielding a positive. And what are the x and y values there? Root 2 over 2 over themselves. You could say they're both negative, I guess, but I'm going to leave that out because I already have the sign down. It is. Okay. That is pretty much what I expect. Now let's talk about what they'll look like on homework. Tonight's homework, if this is going well, tonight's homework is going to well because it's a lot of these. All right. So cotangent squared of negative 7 pi over 3. You don't need to write this, but just so we're clear the order in which we need to do stuff, it's the cotangent that needs to be done first. And after that result is found, then the squared. I know the square is in such a weird place notation-wise, but it's the squares last. Nothing. All right. You don't need to write that, just so you're clear. That's the idea. Find the trig first, then the square. So, negative 7 pi over 3. Pi over 3 is what kind of angle? 60 degrees. And as far as pi over 3 is, this starts at 0. This would be pi. so 3 pi over 3. If I keep going, this would be 2 pi, so 6 pi over 3. So don't I want to go a 60-degree angle a little past that? And so if I were to draw that, I would get a 60-degree angle in the first quadrant. You can put those together. I'm not sure why I do this separately. You get there. You with me? Now let's talk sine. What's cotangent? Actually, let's talk variables. Is tangent x over y or y over x? Tangent is y over x. So cotangent is x over y. And the signs, I think you'll agree, are going to be positive, yeah? All right. And then what is the x for the small side in the 30, 60, 90? 1/2. What's the long side in the 30, 60, 90? Root 3 over 2, which we're going to square. Do you want to carry that out and finish it up, or go on to the sine of 30? I don't care either way. Finish it. Okay. I get 1 over root 3 if I multiply by 2 top and bottom to get rid of the fractions. And then if I square that, it eventually ends at 1/3. All right. Now we need to do the other part. Sine of 30 degrees. That's surely a 30-degree related angle. It's first quadrant, so it's positive. Sine is the ratio of what to what? X and Y style. Y to 1. And so y over 1 is, what's the y side there? It's a short side. So what is the short side of 30, 60, 90? 1/2 over 1. So 1/3 plus 1/2. Here's where you're not going to let me down. You're going to show that you still know how to add 2 fractions. Thanks, sir. Without letting me down. Cry bitter tears make me walk you back to pre-algebra down the hall. What'd you get? I knew you would. Okay. That's what can be expected. Are we done? Okay. Any questions? Oh, yes. I told you that 20 minutes ago, too. Yes.
Do we have to show the work for solving out like the cotangent or not, or if we just know what it is?
You must draw a picture at the very least.
Okay. But if like we know that the cotangent of 60 is square root 2 over 3.
Yes, absolutely. If you bypass this, give me this for a day or two before the square. I don't want too much. Okay, I'm fine with that. So, as Mueller, right? As Miss Mueller so kindly told me, I am dumb and I went the wrong way, didn't I?
Yeah.
Well, you could have told me before. People, what is wrong with you? Geez, now we gotta do. How does that change? Does it change things? It changes this to the triangle's not here but here, yeah? So it doesn't change the numbers, but it does change the sign. This is a negative root 3 over 2, which makes this a negative 1 over root 3. But thankfully, that's where our problems end because the square knocked it out. So would I have got the right answer anyway?
Yeah.
But is my work total nonsense garbage?
Yep.
Yeah, sorry, my bad. Thank you for not letting it go. I appreciate it. Okay. Would you flip this over and let's see if you can do this well without. And my goal is eventually that you can do this fairly quickly. So do on the back of this, do close equal to negative 30. 300, sorry. Positive 300, please. I'm going to walk through this 60-degree angle here. Sine negative. gosh. Are you with me so far? Do you agree with negative 2 over root 3? And when you rationalize it, what do you get? 2 root 3 over 3. Okay. Success? Try cotangent of 350. What'd you say there? Negative 1. Okay. Is that all? Oh. How many of these are there? Let's anticipate, shall we? There are, oh man. This kind of went ham on this baby. All right, that's all right. It'll be good practice. Secant of negative 240. Go through these this week, we'll pick up speed. We're trying to go faster. What'd you get? You got 2, excellent. All right. Secant of 3 pi over 4. What'd you get? Negative root 2. If you can start to say, I know that the reciprocal of root 2 over 2 is just root 2, and bypass all that rationalizing, great. I'm down. Okay? Cosecant of 5 pi over 2. Big on memorization, but in order to save time, do you remember what that eventually cleans up to? 2 root 3 over 3. It's sometimes common for people to say over 2 there, which is silly because the 2's cancel, that's not right. All right, how about secant of pi? What'd you say? Negative 1 or 1? Negative 1, right? Because x is negative over there. Okay. Last 2. mark what? See where that says? No. What'd you get? It is 0. Okay. So check your signs. One should be negative, but the other should be positive. This should actually be a negative here, but it's squared, so I didn't cost me. All right, last but not least. Some of you obviously have these master plan codes, so that's awesome. Let's come up with the rules. Oh, sorry. What'd you get for the secant expression? Negative, it's 2 gradients of root 3 over 2 for the cosine, so the reciprocal of that after all the work is 2 root 3 over 3. 210. It's the same picture. It's x over y. With tangent is cosine over sine, or x over y. And so it's root 3 over 2 over half. I don't know if you showed all that. Or you just jump straight to root 3. But when you multiply, the root 3's go away, leaving you with the normal 3. So what's your final answer? 2 times 3 over 3 is just... How'd you do? Good. Say horrible? Didn't say horrible, did you? I hope. Okay, that is that. You should be good to go on tonight's homework. You have about 7 minutes. So rather than pack up, what's the hardest one? Is there a hard one on here? These are so easy. Let's do 12. Why don't you knock 12 and maybe 13 and 14? Those are the hardest ones. See if those go well. Feel free to, at this point, if you want to listen to music, I don't mind. Or if you want to say, hey, what'd you get with your Math Amigo? That's fine too. But 12, 13, and 14 are the hardest new ones. Let's knock those out.